Yeah, welcome to the lecture on electrical circuit analysis. So, let us discuss today. The lecture is on introduction to AC circuits. So, coming to the learning objectives of this today's lecture is to compare the AC and DC quantities and to define the various alternating quantity parameters and what is meant by alternating quantity, and to define some terms related to the alternating quantities. Okay. So, let us see one by one. Now, first one is a difference between AC and DC quantities. So, what is meant by AC and what is meant by DC? So, if you see that waveform, first one is a waveform. So, AC is maybe it is a alternating quantity, is a time changing parameters. Okay. If you see the waveform, the example for AC waveform is a sinusoidal waveform or sine waveform or cosine waveform. Whereas the DC is a constant, okay, the constant line, a constant line. So, this is the DC waveform if you see in the DC circuit. Okay. So, what is meant by this AC quantity means? So, it is a signal, so AC quantity is a signal which changes its magnitude as well as polarity. That means, polarity means plus and minus. So, when you see the waveform during this first half cycle of this waveform. So, the quantity is positive, during the negative, during the second half cycle the quantity changes to the negative. So, like means it's the value is changes, that is the magnitude is changes and the polarity also changes. So, slowly increasing and slowly decreasing. But coming to the DC, so DC quantity is a signal which changes its magnitude, but does not change its polarity. So, the DC value may be either positive or negative. So, it never changes from positive to negative and negative to positive. So, it maintains the either only positive or negative value. But whereas the AC, it changes this magnitude, okay, positive and negative. So, that means a signal which changes its magnitude as well as polarity we are calling as a AC quantity. So, the signal which is not changing its magnitude and polarity, so which is called as a DC quantity. Changes the magnitude may be changes in the DC, but polarity will not change. Now, use of transformer. Now, see for the AC, the transformer can be used for the AC circuits. Okay, that means the transmission of AC is possible through the transformers, but transformer does not work for the DC quantities. So, therefore, not possible use of the transformer in the DC quantities, that is DC supply systems. Now, distribution efficiency of the AC is very high. The distribution efficiency of the AC is very high, and for the DC it is very low. So, design of that is the reason we are generally we are using the AC supply in our domestic applications. So, in your household, so we are using the AC supply system instead of the DC, because the efficiency is very high for the AC system, and the DC system it is very low. So, design of machine is very easy. Design of AC machine is very easy compared to the DC machine. So, DC machine involving the commutator may be present. So, which converts the AC into DC, that is a commutator is also called as a rotating rectifier. So, that is the designing of this DC machine is very difficult. It is not that much easy. Okay. And coming to the generation of AC is easy compared to the DC. So, from the waveform using commutator only we can generate this DC. See, without the commutator action in the generator, so what we already studied about the DC machines. So, whatever the voltage generated inside the DC machine is AC, but by using this commutator we are converting that AC into DC. So, generation of DC voltage is somewhat complicated, because commutator circuits are involving. So, coming to the application, that means, so which supply system we should prefer, whether AC or DC. So, depending upon the application. So, AC motors and domestic application, industrial supply, etc. For these we can use the AC supply system. For DC application means, so we can see submarines, so aeroplanes, so we cannot use the AC. So, where we cannot go for AC, we are going to use this DC supply system. And see, you take the small toy cars, okay, the kids will play with the toys. So, toys, so we are going to use a DC. So, there is batteries, small batteries and small cells we are going to use these applications, so toys applications. That means, see, we cannot criticize this AC or DC. So, depending upon the application, we are going to use which type of system which is best preferable, either AC or DC. Okay. So, that means, see, this AC is not portable, but whereas DC is portable. See, you are using the mobile phone. So, mobile phone we are using the battery. So, battery store the energy DC voltage. Therefore, so DC can be moved from one place to another place. That means portable. Portability is possible in DC system, but portability is not possible in AC system. Okay. So, these are the some of the advantages and disadvantages, and what are the difference between the AC and DC. So, why we have to prefer? See, depending upon the application only we are going for the either going for use AC or DC. Okay. Now, next one is a definition of alternating quantity. So, I told you, so an alternating quantity changes continuously in magnitude and alternates in direction at a regular interval of time. See here, now I am taking this symbol as the waveform as a sinusoidal waveform. See, this alternating quantity not only sinusoidal waveform. So, you can take any waveform which is changing with the time and polarity. The magnitude of the waveform is changes with time, and the magnitude and polarity of the waveform must be changes with time and changes with time. That means, see, if you are taking the sine wave is the example for alternating quantity, and you can take the cosine wave also example for alternating quantity, and triangular waveform also you can take that alternating quantity, rectangular waveform or sawtooth waveform, any waveform. So, which changes the magnitude and polarity when the time changes. So, those all are comes under the sine, that is alternating quantities. But why we are preferring the only this AC when you are talking about the AC sine or cosine, means when you do the calculations, of this AC problems, the circuits, you are solving the circuits. So, the integration of cos is sine. Okay, integration of cos is sine. Integration of sine is minus cos. Differentiation of sine is cos. Differentiation of cos is minus sine. That means, so if you integrate and differentiate, so it is easy to operate the mathematical operations. So, it is easy to calculate. But if you take the rectangular waveform, triangular waveform, sawtooth waveform, whatever the waveform, so it is somewhat difficult to integrate and differentiate. So, it is somewhat difficult to find out the area and average value and RMS values. Okay. So, that is the reason we are always preferring this sinusoidal waveform as the reference for the AC quantities. Okay. So, that is the only idea, that is it. Next. Now, let us define some important terms related to the AC quantities. First one is the amplitude. So, what is the amplitude? So, amplitude means, so it is the maximum value, either positive value or negative value. So, attained by any alternating quantity is called as the amplitude. See, this amplitude is also called as the maximum value or peak value. Now, see this waveform. So, what is the maximum value? See, if you see the positive side, so maximum value is plus Em. If you see the negative side, the maximum value is minus Em. So, maximum value is nothing but it is the either positive value or negative value attained by any alternating quantity. It is called as a amplitude. Now, what is the time period? Next one is the time period. So, it is the time taken in seconds required to complete one cycle of an alternating quantity is called as a time period of that waveform. So, time period is denoted by T, capital T. Now, see here. So, here time T is nothing but the one complete cycle, the time taken by the waveform to complete one cycle we are calling as the time period of that waveform. Okay. So, here T is the time period of the this given waveform. Now, instantaneous value. So, what is the instantaneous value? Means it is the value of an alternating quantity at any instant. That means instantaneous value is denoted by small letters. That means this instantaneous values changes with time. Now, see here. Now, at pi by 2, at omega t is equal to, now see this waveform, at omega t is equal to pi by 2. So, what is the value? At omega t is equal to pi by 2, the value is plus Em. At omega 2 equal to 3 pi by 2, what is the value? Minus Em. At omega t is equal to 2 pi, what is Em? 0. At omega t is equal to pi, the value is 0. At omega t is equal to 0, the value is 0. So, that is for the instantaneous value. Okay, at what instant and what is the value that at that particular instant. Okay. So, instantaneous value of an alternating quantity at any instant we can calculate. So, now next one is the frequency. So, frequency generally the frequency is defined as the number of cycles per second That means how many number of cycles are coming. So, over a period of time, that is in 1 second how many cycles are there. So, it is the number of cycles that occur in 1 second we are calling as a frequency. So, the units of frequency is hertz. Okay, the units of frequency as hertz, or we can say cycles per second, simply cycles per second. So, the relationship between this frequency and time period can be derived as follows. So, see, time taken to complete one cycle. So, how much time taken to complete one cycle? 1 second. See, that means 1 second, 1 cycle. So, then time taken to complete one cycle is nothing but 1 by f second. Yes or no? Time taken to complete f cycles. F is a frequency, na? So, f cycles is 1 second. So, time taken to complete one cycle is 1 by f second. Therefore, time period t equal to 1 by f. That means the time period is reciprocal of frequency and the vice versa. That means frequency is the reciprocal of time period. So, t is equal to 1 by f or f is equal to 1 by t. So, this is the frequency. So, in India generally the frequency is 50 Hz frequency. So, from Kashmir to Kanyakumari, so entire the transmission line is transmission and distribution lines are designed for the to operate to only 50 Hz frequency. So, if you coming to the USA, so that frequency some areas at 50 Hz and some areas you can take the 60 Hz frequency also available. So, that means once the transmission line and distribution lines are designed, so it is very difficult to change the frequency of the design system. See, we want, if India want to operate the electrical system at 60 Hz, so entire this transmission distribution line from Kashmir to Kanyakumari, Arunachal Pradesh to Gujarat, we have to change entire transmission line system. So, it is very difficult to change the transmission line system because we are already designed to operate only at 50 Hz frequency. That means if you buy any mobile iPhone in the America, so and if you bought if you bring it to the India, so you have to get some adapter to, because the voltage levels and frequency levels are different in USA and the voltage level and frequency levels are different in India. So, coming in India 220 to 230 volts 50 Hz supply frequency single phase AC, whereas in America it is 240 volts 60 Hz frequency some areas and some areas 50 Hz frequency. Okay. Now, the next definition is the angular frequency. So, what is the angular frequency? So, you know that AC, how the AC quantity, AC voltage is generated. So, whenever the conductor cuts the magnetic field, so according to the Faraday's law of electromagnetic induction, whenever conductor cuts the magnetic field, EMF will be induced in the coil. That means, when the rotor is rotating in the generator, so this rotor will cut the magnetic field, so then the EMF is induced in the coil. So, what is that angular speed? So, the rotor rotation is called as angular speed omega. So, angular frequency is defined as the number of radians covered in 1 second. Number of radians covered in 1 second is we are calling as the angular frequency. That means, what is the unit of this angular frequency? Radians per second. That means, with 1 second, how many radians covered by this rotor? How many cycles? How many cycles are covered by this rotor? So, that means radians per second, how many radians it is covered. So, that is the angle covered by the rotating coil. So, the coil is rotating. So, what is the angle it is covered? 0 degree, 90 degrees, 180 degrees, 270, 360 like this. So, pi by 2, 2 pi, so 3 pi by 2, 4 pi. 4 pi by 2 is 2 pi. So, like that. Okay. Now, next one is the form factor and peak factor and crest factor. What is this form factor? What is peak factor? So, here form factor is the defined as it is the ratio of RMS value by average value. It is the ratio of RMS value to the average value, and it is given by form factor equal to RMS value by average value. Now, what is my peak factor? So, this peak factor we are also calling as a crest factor. So, this peak factor is defined as it is the ratio of maximum value to the RMS value, and it is given by, so peak factor is equal to maximum value by RMS value. So, we can calculate the what is the form factor, what is the peak factor for the different waveforms, sine waveform, sinusoidal waveforms, non-sinusoidal waveform, non-sinusoidal waveform. What is the non-sinusoidal waveforms? So, triangular waveform, rectangular waveform, pulse waveform, sawtooth waveform, these all are called non-sinusoidal waveforms. Okay. So, see here for sinusoidal waveform, we can, if we calculate the Im is equal to 2Im by pi average value. So, RMS value you will get Im by root 2, and form factor if you calculate the 1.11 for the sinusoidal waveform, and the peak factor if you calculate 1.414. So, how to calculate this RMS value, average value? Once you calculate the RMS value and average value, then it is easy to calculate the form factor and peak factor. Okay. So, So, how to calculate this RMS value and average value? So, we will see in the coming classes. Okay. Now, last one, now next one is the average value. So, what is the definition of this average value means? So, the arithmetic average of all the values of an alternating quantity over one cycle is called as the average value. Okay. Now, see here you are taking the sinusoidal waveform. So, you take the arithmetic average of all the values, okay, of any alternating quantity over a one period, one cycle, over a one cycle is called average value. Now, see for sinusoidal waveform, for symmetrical waveform, what is the average value? So, for symmetrical waveform, the average value becomes 0 because so positive cycle and negative cycle will cancel with each other. So, for symmetrical waveform, the average value calculated only over a one cycle, okay, because one cycle becomes equal to 0. Okay, that means over a one cycle equal to 0. Therefore, you have to calculate the average value for only half cycle of the any symmetrical waveform. Therefore, average value is given by it is the area under one cycle by base value, area under one cycle by base value. Okay. Now, how to calculate this average value? So, we will see in the coming classes, but for that let me take this example. As for sinusoidal waveform, I am calculating the average value. So, average value, so V average, now it is a voltage waveform. So, V average is equal to 1 by 2 pi. So, what is the total time period? What is the total time period? T is equal to 2 pi, that means T is equal to time period is 1, complete cycle is 2 pi. So, 1 by total time period 2 pi, integral of 0 to 2 pi. So, 0 to 2 pi V of omega t, okay, V of d omega t. Now, see here. So, from this you can easily calculate that I average also. What is I average? So, I average is equal to 1 by 2 pi, integral of 0 to 2 pi I of d omega t, okay, I of t into d omega t. Therefore, here I is nothing but our I m sin omega t. Therefore, so we have to calculate the average value only for one half cycle for the symmetrical waveform. Therefore, I is equal to I average is equal to I m by pi, sorry, 1 by pi integral of 0 to pi I t omega t. So, therefore, I average is equal to 1 by pi. So, you substitute I is equal to I m sin omega t. So, I average is equal to 1 by pi into 0 to pi I m sin omega t d omega t. So, what is sin omega t? Sin omega t differentiation is minus cos omega t. So, substitute the upper limit and lower limits, then you will get the I average is equal to 2 I m by pi, that is 0.637 I m, that means 63.7% of the maximum value. So, 63.7% of the maximum value for the sinusoidal waveform. Okay. So, next one is the RMS value or effective value. What do you mean by this RMS value or effective value means? So, RMS value of n alternating quantity is the steady state current or DC current which when flowing through any given resistor for a given time produces the same amount of heat when produced by the alternating current flowing through the same resistance for the same time. That means, you take one resistor, okay, you allow the DC current, into the resistor. Okay. So, what is the, how much amount of heat is produced? How much amount of heat is produced? You note it down, okay, you please record it. Next time you allow the AC current through the same resistor and over a same period of time. If it is 1 minute means DC current 1 minute, or if you allow, so AC current also allow the 1 minute, same amount of time. Then that RMS value of this AC current is equal to the DC current. The RMS value of AC current is equal to the DC current. So, that is nothing but our RMS value or effective value. So, RMS value of an alternating quantity is the steady state current or DC current which when flowing through a given resistor for a given period of time is the produces the same amount of heat as produced by the alternating current flowing through the same resistance for the same time. Therefore, this RMS value is given by square root of area under the squared curve by base value. RMS means root mean square value. Okay. So, square root of area under squared curve, the area under the curve square by base value. So, if we calculate the RMS value for the sinusoidal waveform, okay. So, how will you get it? So, I RMS is equal to square root of 1 by 2 pi. So, what is the total time period is 2 pi. So, 0 to 2 pi, the limits one complete cycle time period. So, I square d omega t. Then what is I is equal to? So, for this from this waveform I is equal to Im cos omega t. Therefore, you substitute that I RMS is equal to square root of 1 by pi 0 to pi. So, Im square sin square omega t d omega t. So, how to write this sin square omega t integration? So, it is very difficult to calculate the sin square omega t integration. So, you write 1 minus cos 2 omega t by 2, and if you calculate that you will get the I RMS is equal to Im by root 2. That means 0.707 into Im. That means 70.7% of the maximum value. So, which is equal to the DC current value. So, that is what the RMS value. RMS value is the equal to the DC current. So, when the two currents were allowing, so the amount of heat produced must be same. Those two currents we are calling, we are taking into the considerations. Okay. So, next we will see in the next class. So, how to solve this problems on this RMS value, how to find the RMS value and average value. Okay, we will see in the next class. Okay, thank you.